welcome to another episode of Old Guy Physics, and this video is on our second step or second stage of projectiles. The first video was on projectiles that are traveling horizontally only, and now we're going to go to those projectiles that have both an up and down motion. So if you check out this picture right quick, we've got the ground and we've got a cannon set up over here. And the cannon's going to fire a projectile or a cannonball, and it's going to land over here somewhere. And that curved pathway is called a trajectory. So one of the things that they'll say in this problem is that they'll tell you the initial velocity. Let's make one up, like 25 meters per second. And then let's give it an angle of 40 degrees. So they're shooting this projectile 25 meters per second at a 40-degree angle. Okay? The first thing we should remember is that whenever you shoot something at an angle, there's going to be a v sub x and there's going to be a v sub y, or there's going to be horizontal and vertical components to that diagonal projectile. And so the 25 meters per second is the hypotenuse, and the angle right here is 40 degrees. So I'm encouraging all of my students to solve for the v sub x and v sub y using polar rectangular. If you don't know what that is, then the other alternative is that v sub x can be solved for by using the cosine and solve for the adjacent side, and then you could use the sine function to solve for v sub y, which is going to be the opposite side. And that's one way to work it. But the polar rectangular, as my students have found out, seems to be a little bit easier. Now, before we get too much farther, I just want to remind all my students that the steps for working these kinds of problems are listed right here on the whiteboard, and it's always up, and it's always available. And if you have questions, just ask me. So running this polar rectangular, it's this simple. 25 at a 40-degree angle gives us 19.15 meters per second for v sub x, and 16.07 for the meters per second for the v sub y. So now we have the x and y components. What that means is that the projectile is traveling to the right with a constant velocity of 19.15. And then the v sub y is telling us that it starts in the up direction at 16.07, and it's going to go up in the air and it's going to come back down. Now, that should look an awful lot like step number 2, which I call little guy math, only because I draw a little guy right there in the center, and it should remind you of the vertical motion problems that we worked where the guy was throwing the ball up in the air and it came back down. This 16.07 is going to be the velocity that the ball is going up with. And from that, we could solve for the time, we could solve for the distance to the top, and likewise we have the distance back down, which is also helps us to solve for the time down, and we know that the velocity when it reaches the ground is the same as the velocity it started with. So, again, those free fall formulas are going to come in handy here. We've got v is equal to 10t, let me put a y there, and d sub y is equal to 5t squared. Those are the free fall formulas. You'll see them over there. And so if we have a velocity of 16.07 right there, then when we divide by 10, which is what we're doing with this equation, that tells us that the time up is 1.61. I'm going to round to 2 decimal places. So 1.61. Now, because it's on level ground, the time up and the time down should be equal. So 1.61 plus 1.61 should give us 3.5 2 seconds, and that's total. So that's the total time in the air. Now, if the question happens to ask, what was the distance to the highest point, then we're going to substitute the time value into this equation, and we're going to take 1.61 squared times 5 equals, and that tells us that the highest point was 12.96 meters, and it was also going to fall for 12.96 meters. And so we're quickly filling in the chart here so that we know the values for the V, D, and T on both sides, and then we're prepared to answer any of the other questions. Now, in step number 3, D sub x is equal to V sub x times T, which is the horizontal distance that the cannonball lands away from the cannon. So we have a horizontal velocity. That's this one right here, 19.15. So 19.15 goes in the equation here. The total time in the air is 3.22 seconds. So that goes right there. And then we just have to multiply. 19.15 times 3.22 equals 61.66 meters. And that's D sub x. Now, all of these problems work predominantly the same. We've got step 1. Let me change colors here right quick. There is step number 1, which is the triangle right here. Then there is step 2, which is the little guy math. And then the last and final step is step number 3, which is the horizontal distance that the cannonball lands. And all of those, like I said, work predominantly the same. And once you get used to doing those 3 steps, you should get the answers right every single time. If you have any questions, check with me in class, and have a nice day.